In this example, we're going to be taking the golf award that we created in the 3D assembly tutorial, and we're going to show you how to create the toolpaths in order for you to cut this on your CNC. We'll be demonstrating both the 3D roughing and finishing toolpaths, as well as showing you how you can utilise the rest machining technique to refine the finish of your 3D toolpaths and optimise your machining time. But first we need to close out of this part, so we'll go to File, Close. So to start this tutorial, we're going to open up the golf award file that we created previously. So we'll go to Open an existing file, and from the project folder we'll choose the golfaward.crv file and click Open to open that up. And you'll see that then placed on the workspace in the 2D view. And if we then use this option to tile our windows vertically, we'll then see the 2D view on the left and the 3D view in the right. Now, the strategy that we're going to use for this requires us to have a vector to isolate our tooling. Because this award is in a dish shape, we could essentially cut this into the top of an already existing plaque, or maybe even a cupboard door or a cabinet to display golf awards in. And to do that, we need to isolate our tooling to only cut what's inside the dish. So there are a couple of different ways that we can do that, but in this demo, we're going to find out the diameter of this dish, and we're then going to create a vector to fit that. So if we select this dish, and we'll go over to the Set Selected Object Size, in the form we're going to see that it's actually 7.5 inches in diameter. So if we close out of the form, and then go up to our Draw Circle tool, what we can do here is set our center point to X0, Y0, which is right in the middle of our job. We're then going to switch from radius to diameter, and we're going to specify the diameter of 7.5 in there, and then click Create, and then close out of the form. And you'll see now that we have a vector circle around our golf award that's exactly 7.5 inches in diameter. So with that, we'll go over to our Toolpaths tab, and we're going to pin that down. So now we've got both the drawing and the Toolpaths tab open at the same time. So to make sure that both our 2 and 3D views are visible in between that, we'll click our horizontal views again, and that will reset the sizing. And again, we can see our 2D view on the left and our 3D view in the right. So we put the 3D view back in Z, and we'll look straight down on that. Now, as always, before we look to apply Toolpaths here, we need to set up our material. So under Material Setup, we'll click Set. So our material thickness is 1/2 inch, which is correct. Our XY dating position is going to be in the center, which is good in this case because it's right in the center of our plaque, so it'll make for a more efficient toolpath. But if you wanted to, you can always change that if you're more comfortable with setting it at the bottom left. So you'll see that the icon changes to show that, and the XY dating position is shifted. But in this case, we're happy with the center, so we'll just reset that. Moving down in the form, we're going to be zeroing from the material surface, and this is an important point here because we're going to be cutting directly into the material surface, so we need to ensure that our material is completely flat. We're not going to create a gap above the model because again it should be right at the surface of our material. And our rapid Z gaps, we're going to change this to be a clearance of 1/4 inch. So that's going to move the tool up from the surface of the material by 1/4 inch. So hopefully that's going to avoid any hold down methods that we're using, any screws that are holding our material to the spoil board. And we're going to make the tool go up to 1/4 inch above the material before we plunge in. Our home start positions are set at 0, 0, and the Z gap above material, we're going to change that to also be 1/4 inch. So that's pretty standard there, and then we can click OK. Now, the first toolpath that we're going to create is going to be a 3D roughing toolpath. So on the third row of toolpath operations, we'll click the icon here for 3D roughing toolpath. And the tool that we're going to be using in this case is the 1/4 inch end mill. So that's already been pre-selected. So we can click the edit box just to check over the parameters, just to make sure that they're safe and appropriate for our setup. And if we did want to make changes here, it would only apply to this toolpath, leaving the parameters saved under the 1/4 inch end mill in the tool database unaffected. Now, for the machining limit boundary, we're not going to be using the model boundary or the material boundary because we've already created this circular vector that we want to machine up to. So we're going to select selected vectors in this case, making sure, of course, that we've got the circular vector selected. And we're not going to use a boundary offset in this case. We don't want the tool to rise outside of the dish at all there, so we want it to remain inside the dish. We're going to leave a small amount of material behind for the finishing toolpath, so under machine and allowance. We'll leave that at 0.03 inches, and that's perfect for what we're doing here. For our roughing strategy, we're going to remain with Z level. Now, we could choose 3D rastering if we like, but in this case, I think we'll benefit from the Z level roughing as it won't take as long. And the cutter that we're going to use to do our finishing is going to be pretty strong, so I think we'll be okay with that. And we're going to raster along the x-axis, so we can leave the raster angle at 0 degrees. And we don't need any ramp plunge moves in this case, we'll leave that unchecked. And we can just come down and we'll name this 3D roughing dash 0.25 nmil. And that's a good little tip, just to use the tool that you've used in the toolpath in the name so you can see at a glance what we've used previously. And then we can just go ahead and click calculate. And now that's been calculated for us, you can see our toolpath in the 3D view here. So we can go ahead and preview the selected. And it's a good idea to take a look over this closely. And if it doesn't look right, then we can go ahead now and make our changes before we cut this on the machine. But that's exactly what I expected to happen here. So it's pocketed down, removed the majority of the material before we go in with our finishing pass. So that's looking great. So we can close out of the preview. We'll put the 3D view back in Z, and we can go in now and look at our 3D finishing toolpath. And in this case, the tool I'm looking to use is the 1/8 inch ball nose. But if we needed to change the tool, then with that selected, we can click remove, and we can go in and select a different tool. And from the tool database, I'll just reselect the 1/8 inch ball nose, check over the settings, and click select to add that back in. And now temporarily for this particular toolpath, I want to edit this tool. So we can use the edit option here. And I'm just going to lower our step over down to 8%. So that's just going to give us the best detail that we can get from this particular cutter. And that way we're going to know whether we need to come up with a different strategy to bring back the detail that we've missed. And we might see some other things that we're unhappy with. So for now we'll click OK to accept that. Our machining limit boundary, once again, is going to be the selected vector, and we don't need a boundary offset, so we can move on down in the form to choose our strategy. And here I'm going to choose the offset strategy, so we're going to start in the middle of our model, and we're going to slowly start to work our way out until we reach the edges of our model. We could use a raster strategy, in which case it would move backwards and forwards in the x-axis, but that could leave some unwanted marks that we don't want to see here. And because of the circular shape of our dish, in this case I think the offset strategy is going to be the best fit. Our cutting direction is going to be climb here, so it's going to start in the centre and work its way out. But if we were to see some radial lines within the piece, because our tool is dragging a bit as it moves to the next line of code, to the next circle, then we could look at using the step over retract. And what would happen if we choose to do that is it would complete one circle, and then it would retract and lift the tool out, and then drop down again to do the next circle. And by using this method, you're less likely to see these radial lines within the part. But in this case, we're not going to choose to do that. I think we'll be okay here. So we can come down and give this one a name. So we'll go for 3D finish, 0.125, ball nose, nmil, and then we can calculate that. Now, because we're using such a small tool, it's just going to take a while to calculate that. And there we have it. So now that's calculated, you can see that in the 3D view. So we'll go ahead and we'll preview that toolpath. And as always, once that's done previewing, it's a good idea to have a really good look over this just to make sure it's exactly what you were expecting to see, because any anomalies here will be reflected at the machine. And if there's any area that you're unhappy with, then we can go in and correct that before we actually go to cut this. So to get a closer view, we can go ahead and maximize the 3D view. And we'll just have a look around this, and that's looking pretty good. But we can see these faint ridges at the bottom of these elements where the 1/8 inch ball nose has left some cusping around the edges, and some tool marking all around the wreath and the ribbon, and in areas up here like the top of the golf ball. Now this is something that we could look at hand finishing when we've cut the part, or we could get the CNC machine to do the hard work for us. So we could look at using a smaller tool to fit within these areas. But if we switch to a smaller tool to machine the whole thing, then it's going to take a lot longer to machine this. So we could look at the option here of using rest machining. So rest machining is an acronym for remaining stock machining. It's a technique which uses multiple tools to try and efficiently optimize machining time and material removal, where we can use smaller tools to machine away material for better results, efficient machining, and ultimately prolonging the lifespan of your tools. So let's go back into the Finishing Toolpath and we'll look at using the rest machining option to get a better finish. So the rest machining option can be found here in the format, and as you can see, it's currently greyed out. So in order for us to make use of this, we'd need to add in an additional tool or tools into our list. Currently, we only have one tool, the 1/8" ball nose, listed there. So I'm going to use the select tool option here, and we're going to select a brand new tool. But in this case, the tool doesn't actually exist. So we're going to look at adding in a new tool into our ball nose list. So this is going to be a tapered ball nose. And to do this, we're going to select the ball nose group. And we're going to come down to use this option here to add a new tool under selected tool or group. We're then going to change the tool type to be a tapered ball nose. We're already working in inches, so we're going to change the diameter to be 0.25 inches. Our side angle is going to be 3 degrees, and our tip radius is going to be 1/32. And we can get the software to work out the decimalisation of this for us. So if we put in 1 divided by 32 and press equals on the keyboard, it will give us the decimalisation of that. We're going to say that we've got 2 flutes on that, and then we're going to create the settings, and we can check over these, over the cutting parameters. So the past step there, that's fine. Step over, we're going to lower that, so we're going to look at using 7%. Clearance past step over will make that 7% as well. And the feeds and speeds are all looking fine, but depending on the material that you're using, you might want to look at changing these. And if so, you can do that here. And then we're going to click apply to commit those settings, and then choose select to select that tool, which is then added into the list along with our 1/8" ball nose. So now the software will machine everything with the 1/8" ball nose first, and then it will go and clear that up with the tapered ball nose. And you'll also notice now that we've got access to the rest machining section of the form. And the rest machining technique can be controlled with the slider, where you can choose your minimum detail to remachine. And this can be anywhere between a coarse and a fine finish. And this will determine which areas are worth remachining using this tool. So let's have a look at the effects of some of these settings that we can use here. So for example, let's just go all the way over to a fine finish. So we've got maximum detail in there. Next, we need to specify a boundary offset. And the boundary offset that we set within the rest machining form will apply to all of the tools in the list except for the first tool, because the first tool's boundary offset is set by this boundary offset option in the machining limit boundary section of the form. The boundary offset within the rest machining section of the form is where we specify a boundary around the areas that we're looking to machine again. So for now, we'll just leave that at 0 and just see what the effects of that are. And now we can look at the strategy used again on a per tool basis. So you'll notice now that the name of the tool that we have selected is displayed next to strategy. Okay, so here we're looking at the tapered ball nose, and we can change that from an offset to a raster strategy. If we then instead select the 1/8" ball nose from the list, you'll see that the tool name has changed next to strategy, and again we can select between offset and raster for this tool as well. So the tool name in this part of the form is just indicating which tool we're actually specifying the strategy for. Okay, so let's just switch back to the tapered ball nose. And for this tool, we're going to go with the offset strategy so that it follows the shape of the parts that we want to remachine. And for the 1/8" ball nose, we'll use a raster strategy. So if we switch between those now, tapered ball nose using the offset strategy, 1/8" ball nose using the raster strategy. So then we can go down and calculate this, and we can take a look at the effects of these settings. Okay, so now that's been calculated, you can see the toolpaths in the 3D view, and the software's opened up automatically the preview toolpaths form. And you'll see that we've got 2 3D finish toolpaths now, so we've got a clear and a 3D finish. So the clear is using our 1/8 inch ball nose, and I'll just undraw the visibility of that there. And the second 3D finish toolpath is using that tapered ball nose. So this is the rest machining part of that 3D finish toolpath. And if we switch that toolpath on its own, we can take a look in the 3D view just by looking at the toolpath itself, where that toolpath's actually being applied. So you can see here that we've actually got quite a lot of areas that have been remachined. There's quite a lot to clear up around the edge of the dish, which isn't actually all that necessary because I'm fairly happy with the result of the dish. And I'm choosing to use the rest machine in this case, more so to accentuate the detailing of the golf award design. So to hone in more on just this area rather than the outside of the dish, we can just go back into the 3D finish toolpath. We can just look at reducing the minimum detail here. So it's also worth mentioning at this point that the finer the detail that you choose here, the longer it's going to take to machine. So the added bonus of us wanting to reduce the detail in these areas is that we're actually going to get a shorter machining time. And in this case, I want to try just around halfway. So to do that, we've got these 3 notches, one for each end and one in the center. So if we double click on that second notch, you'll see that that's placed that exactly in the center between coarse and fine. And if we wanted to, we could further refine that by typing in exact values into the minimum detail box there. And now we've lowered the minimum detail, we can go ahead and calculate that again. And once the software has finished calculating that, we can take a look at the 2 toolpaths that we've created. So we can undraw the visibility of the 3D finish clear, which is using the 1/8 inch ball nose, and just look in isolation at the 3D finish using the tapered ball nose, which is the rest machining part of our toolpath. And you can immediately see the difference now in the 3D view. So it's just restricting itself to the edges of the design, which is exactly what I wanted. So we've got no toolpathing around the edge of the dish here or any other unwanted areas. So you can see how using the minimum detail slider, you can really hone in on the areas that you're looking to refine. And we can go ahead and preview the effects of that now. So with just that 3D finish toolpath selected, we can use preview selected toolpath. And if we zoom in now to take a look at the effects of that, you can see that's not too bad at all. So we've cleared a lot of the ridges that were left behind by the 1/8 inch ball nose. But you can also see that now we're kind of getting these additional tool marks around the outside of these elements. So almost like a halo effect in these areas. And this is actually caused by the offset that we've selected for the tapered ball nose. So currently we've got a 0 offset, and we can look at eliminating these areas by increasing that. And to do that, we'll go back into the 3D finish toolpath. And from the boundary offset within the rest machining section of the form, we can look to put in a very small offset there. So we could put 0.02 of an inch, for instance, and then go ahead and calculate that again. Undraw the visibility of the clear pass as well, and then we can preview that again. And you can see that that's now cleared up those edges really nicely. So we've got none of the tool marks around the outside, and it's much smoother in these areas, so we haven't got that halo effect anymore. And we've got all of the detail in here, so we've really reduced the cusping that was present around the edges of these elements here, and at the top of the golf ball as well. So we can see now that we have a much better looking part here. We managed to reduce the tool cusping marks and it's looking much sharper. And because we've used 2 tools, it's much more of an efficient strategy than if we were to just use the tapered ball nose to finish the entire part. And with that completed, now we can close out of the preview toolpaths form. And the next thing that we're going to look at is adding in our text to our ribbon. And for that, we're going to be using a VCarve toolpath. So we'll put our windows in horizontal view again. And I'm going to come over to the 2D view and I'm going to pick the text for the hole-in-one. And with that selected, I'm going to come under toolpath operations, and on the second row, I'm going to choose VCarve/engraving toolpath. From the form, the first thing that we're going to look at is the start date. So we're going to be starting from the top of the material here. So we can leave that at 0. The tool that we're going to be using, we're just going to the tool database by clicking select. In this case, is going to be the 60° 1/4 inch V-bit. And we can just check over the parameters again, just to make sure that they're safe and appropriate for our setup. And we can click select, choose that tool. We don't want to use clearance tools in this case, and we can come down in the form. Don't need to worry about this section, but we do need to have a look at this part here. And that's the option to project the toolpath onto the 3D model. Now this is important because right now if we were to cut it the way it is without selecting that, with the difference in shape heights where the ribbon bends round into the background of our model, the VCarving would actually get shallower in this area and deeper towards the centre where there's more shape height. So to counter that, if I choose to project the toolpath onto the 3D model, it should track the shape height along the ribbon here, and we'll get a consistent depth in the VCarving on the surface of the ribbon itself rather than the material. And with that done, we can go ahead and give this a name. So we'll just call this VCarving and 60 DG for 60 degree V-bit. Then we can go ahead and calculate it, and we can see that they're represented in the 3D view and in the 2D view. And we can click Preview Selected Toolpath, and you can see now that that's exactly what we were expecting there. So that's following the shape height of that ribbon perfectly in those areas. So we've got a consistent depth in all the characters. So I'm really happy with this final part. It's looking very polished. And by utilising the rest machining, we've been able to retain all of this detail in the wreath and the banner without any of the cusping or tool marks across the surface. So at this point, we can now go ahead and save our toolpath to output to our CNC machine. To learn how to do this, please refer to the dedicated Toolpath Saving Guide tutorial that you can find in the related video section on this page. And once you have done that, the only thing left to do here is to save our project so it's available to access at a later point. So we'll go to File, Save As, and in the project folder, we're going to call this Golf Award 3D Toolpaths. Click Save or press Enter. And that's now in a safe location for access at a later point.